All right, hello Carson and whoever else is watching this video. We are going to do this section, which is the discriminant. You have 1 page of notes. There's no backside to this. And then I'll tell you what to do for homework. I'm not going to have you do all of the problems, so I'll cut it down. The one side I'll make you do all of them, but the other side, no. So, one thing, we are kind of on this quadratic train right now. We did linear functions for the first 2 days. Yesterday we did factoring for quadratic functions. Typically, we want to factor. Want to factor. To find. What do we find when we're factoring, when we're breaking stuff down?
Simple stuff.
We're finding the solutions, which on the graph are the x-intercepts, or we call them like zeros sometimes, okay? So we typically want to be able to factor a function, right? We want to factor it because even though sometimes they're unpleasant, right, to do, it's easier than doing the quadratic formula, okay? So typically we want to factor, but you every once in a while will encounter examples that look like this. X squared plus, let's say 5x plus 12, let's say. And that looks like a simple trinomial, right? And we're multiplying to get 12, but when I add them, give me 5. Okay, so multiples of 12 would be like 1 and 12, or 2 and 6, or 3 and 4. Which combination will give me 5 when I add them?
3 and 4.
None of them. So that doesn't mean this thing doesn't have zeros. It just means those zeros are probably ugly decimal numbers. And to find them, we have to use the quadratic formula. Does that make sense? So sometimes we can't.
Why do we need this though?
Sometimes we can't factor. And that's just the way that it goes, okay? And when we can't factor, we use the quadratic formula. Part of the quadratic formula is something that's called the discriminant. We talked about all this before. I'm going to write the quadratic formula over. I know some of you are still writing. I'm going to write the quadratic formula over here.
You have the quote thing memorized?
What? Oh, the negative boy, whatever. You want me to say that? Okay, so if you like the riddle, I'll play the video here at the end if you want me to play that. But here's the riddle. A negative boy couldn't decide whether or not to go to a radical party, because that's a radical symbol. But being squared, he decided not to go and missed out on 4 awesome chicks. The party got over at 2 a.m. There is the riddle. Right?
I just have it memorized.
Exactly.
Actually, when they give me plus 1 squared,
Yeah. So now the discriminant part. So this is the entire quadratic formula. The discriminant part is just this chunk that's underneath of the square root. It does not include the square root. Look at this part right here. Circle that. Does not include the square root. Okay? Just the b squared minus 4ac. Just b squared minus 4ac. That's the discriminant. It's just a piece of the quadratic formula, but that discriminant tells us some things about our quadratic function. So here are 3 scenarios that you could have. Okay, look at these graphs. So the first one, actually the middle one is what I'm going to talk about first. That middle one is what usually we have happen, and that is having 2 places where it crosses. So this is where 2 solutions happen, and you can abbreviate if you want to. We have 2 places where it touches. Okay, every once in a while we'll get it where we have this, and our vertex will be on the x-axis, so it'll just come and touch and then go back up where we have 1 solution, okay? Or sometimes we'll have it where this happens down below here, where our parabola is either up above or down below and not touching, which means we have no solutions. You can either write it with a circle and a line through it, or you can put no solutions, okay? Now, let's talk about like when 2 solutions would happen, or when 1 solution would happen, okay? So 1 solution happens right here when your discriminant is greater than 0, and that is meaning like a positive number. So let me give you an example of like the square root of 4. Our discriminant would be 4, and this is a positive number, okay? They are saying that if that number is a positive number, we have 2 solutions. Where do the solutions come from? If this was inside the square root, we would have plus and minus. Something plus this and something minus this. That gives me 2 answers, right? Okay? But let's say instead that was the square root of negative 4. So our discriminant would be negative 4, and that's negative, And we still have plus and minus, but the square root of a negative number is imaginary. It doesn't exist. That's why we have no solutions, right? Okay. If our discriminant, though, is 0, we still have plus minus the square root of 0. But something plus 0 is the same thing as that thing minus 0, right? Plus 0 minus 0 is the same thing, so we only have one solution. Does that make sense? Okay? So your discriminant will tell you those things without having to do the entire quadratic formula. Reese, put your phone away. Okay? So we're going to go ahead and do that, and we're going to see each of these three scenarios. So on number 1, we're just calculating.
So why is it not the first
What do you mean?
one? Like they all, oh, because it's equal to 0?
Uh-huh. Yeah. Yeah. If it's equal to 0, it's one solution. If it's a positive number, it's two solutions. If it's a negative number, it's no solutions. Uh-huh. Okay. So b squared minus 4ac is what we are trying to do, just the stuff underneath. This is what the discriminant is. Okay? So I still go through and I label a, b, c. Okay? What number do we use for a if this is my equation? 1. It's the number in front of x squared, right? b is negative 3. C is negative 5. So b squared would be negative 3 squared minus 4 times a is 1 times c is negative 5. Yeah? I'm just plopping all that stuff in there. Okay, what is negative 3 squared? 9. Positive 9, right? If I do negative 4 times 1 times negative 5. Is it positive 20 or negative 20? Positive, because two negatives make a positive. So 9 plus 20, my discriminant is 29. And 29 is a positive number. So if I were to graph this parabola, how many places would he cross? 2 solutions. Right? Happy with that? 29 is the discriminant.
How did we get 2 solutions?
That's what's underneath of the square root.
Because it's positive.
Because it's positive. Okay? We'll do the next example and we'll see if you catch on. So number 2.
What's positive?
What? 29 is a positive number. Okay?
So it's
Number 2. Okay, watch number 2, Riley. Number 2 is not ready to go. Because you have to have it set equal to 0. So the 72 is in the way. Let's add the 72 over. So 2x squared minus 24x plus 72 equals 0. Okay, now he's ready to go. Let's find a, b, c, and plug them in. So a is 2, b is negative 24, c is 72. So we're going to do b squared minus 4ac. We're just doing the discriminant part, okay? If I do b squared, it's negative 24 squared minus 4 times a is 2 and c is 72. All right, good?
hang on. So negative.
I'm going kind of fast, so make sure you're staying caught up.
Square.
Okay? All right, if we take negative 24 and square it, this is 576. Okay? If you take negative 4 times 2 times 72,
So
is it going to be positive or negative?
Negative 8 times.
Negative
Well, minus, yeah.
576. So your discriminant is 0. And if your discriminant is 0, it's not crossing at 0. It just means it has one solution. One solution. Okay? Number 3, is he ready to go?
Yeah.
Yep. A is 7. B is negative 3. C is 2. So b squared minus 4ac. Here we go. B squared is negative 3 squared minus 4 times a times c.
Okay, so it'd be
9
minus.
minus, because it's going to be negative, 4 times 7 times 2. Or I do this way. What's 4 times 2? 8 times 7 is 56. You can multiply them out of order if you want to. 9 minus 56 is negative 47, I believe. Okay? So no solutions.
9 minus.
How's come there's no solutions?
Negative.
Because it's, and when we do the quadratic formula, it would be a negative inside of a square root, which is imaginary, and we cannot have that. So this thing would not cross the x-axis at all, right? Okay, is this thing going to be a smiley face or a frowny face?
Smiley. Smiley.
Look at the original
Frowny
equation.
face.
It's a smiley face.
The first number is
Oh, it's positive.
positive 7, so it's going to smile. But if it smiles, we know it doesn't touch, so it's all the way up here, right? So it has no x-intercepts, but it's still, is a smiley face. Okay, make sense?
Could be farther up than that.
It could be farther up than that. Actually, the y-intercept is 2, so I know at least it's touching here at 2, right? Okay. All right. Now we're going to go down and do the entire quadratic formula all the way through. One of the things I set up above was that the quadratic formula can solve all quadratic equations, not just ones that can't be factored or can be factored. It will do everything. Okay. So number 1, we're going to do everything all the way through ABC, and but it's not ready to go yet.
Minus 15.
Let's move the 15 over. So minus 15, minus 15. Okay. So x squared, and then what?
Minus 2x.
Minus 2x.
Minus 15.
Minus 15 equals 0. Okay? All right, then we label ABC. Okay? A is what?
1.
1. B,
Negative 2.
negative 2. C,
Negative 15.
negative 15. Okay, so now we're going to do the whole quadratic formula. It's right here if you need to see it. Right there at the top. This whole thing. So x equals, okay, negative b. But what if b is already negative?
It's positive.
It makes a positive 2. Plus minus square root of b squared. What's negative 2 squared? 4. Minus 4 times a is 1 and c is negative 15. And that's all over 2 times a.
Would that be negative 60 on top?
Wait, what was A?
Yes,
Was
wait.
A X?
A was 1.
That was
Okay.
always
Yep,
the
it's just the
answer.
number that's in front of that x squared. Okay? All right, now we're going to simplify. So x equals, sure,
No.
2 plus minus. Okay, this number right here. This is 4, and then negative 4 times 1 times negative 15.
That was 6.
Is that going to be a positive 60 or a negative 60?
Positive.
Positive 60, because there's 2 negatives, right? What's 4 plus 60?
64.
64, but that's underneath of the square root, and we have to take the square root of that,
8.
which is 8. It comes out nice, right? All over
2.
2. Now, because this comes out nicely, we are going to write our answer as 2 separate pieces.
X equals
So we've got
5.
2 plus 8 over 2 and 2 minus 8 over 2. 2 plus 8 over 2 is
3.
5. And 2 minus 8 over 2 is negative 3. Okay? Now, the fact that I got 2 numbers that don't have decimals, they're decently nice numbers, right? 5 and negative 3 means that
They're the
this could have been factored, right? What do you multiply to get negative 15 when you add them give you negative 2? Negative 5 and positive 3. But when you set them equal to 0, it ends up being positive 5 and negative 3, right?
Huh.
So we could have factored this down as a simple trinomial rather than doing quadratic formula. But do the quadratic formula. Don't just like try to factor it down, even though, we know it comes out nice. Okay? So, yeah. All right, number 2. What? If it doesn't come out nicely, we just leave it. We're going to do that in this number 2. You just leave it as a square root. Okay, so number 2, is he ready to go?
Yeah.
Yep. A is 2, B is 7, C is negative 1. Okay. All right. Negative B will be negative 7 plus and minus the square root of, what's B squared?
49.
49 minus 4 times A times C all over 2A.
So 8 plus 49.
Okay. This is 49.
57.
And negative 4 times 2 times negative 1 is a positive 8. So you said 57, and that's under the square root. Does the square root of 57 come out nicely?
No.
No, so we just leave it as negative 7 plus and minus the square root of 57 all over
4.
4. And that's all. Okay? If you...
Wait.
Mm-hmm.
Can you?
Yep.
So is it plus 8 or minus 8?
What would that be then?
This would be plus 8 because negative and negative makes a positive.
What would that
Yes.
be then?
So There's still two solutions there. If you plug that into your calculator, you end up getting 0.13. I did this earlier. 0.13 and negative 3.53, I think, something like that were the two solutions that we got. Okay, you can leave your answer as -7 plus and minus blah blah blah, but just know that that just means there's two answers, but they're ugly decimals. You can leave it as the circled one, okay? But that's what that means. They're crossing at those two ugly decimal places.
What
Okay.
if it can be set apart? Do you want us to say?
Like right here. Like that's what this one was. The square root of 64 did come out as 8, so we went ahead and added 8 and subtracted 8. Yep. So if it can, you'll do that. If it can't, you'll do that. Okay? Good? Now, real quick, let's say instead that we got -7 plus and minus the square root of -57 over 4. How would you write your answer? It would be no solutions, but write this as -7 plus and minus the square root of 57. 57 I all over 4. So that negative will become an imaginary number. Okay, so that's how you'll write your quadratic equation when there's no solution. Okay, happy with that?
Wait.
Good.
So technically, our
So
two
if it's-
answers are two.
This is a hypothetical. This is saying if it was -57 instead of +7, right? +57. If it was -57, you would make it look like this. Square root of 57I. Okay? Okay? All right. On homework. This page, do all of them. Some people were confused about number 3 where it says A, B, C, D, E, F, right? They're saying if the discriminant is 8, how many solutions would you have? If the discriminant is 1, how many solutions do you have? If the discriminant is -10, how many? So the A through F should go like really fast.
Oh, I already did those.
Yeah, those should go really fast. So don't get confused on what they're asking. On the back side, just do the left-hand column so you can extend your work out if you need to do your workout. But make sure that you're answering all the questions because they want you to find the discriminant and the number of solutions and the entire quadratic formula. So there's like 3 parts basically to doing those. Okay? Wait a minute.
So 6, 7, 8, 9, 10, and then all on the back.
No. Yes, 6, 7, 8, 9, 10, and then all on this page. 1 through 5 all, and then just 6 through 10. So you don't have to do the right column. Okay? Good? Yes? Okay, use your time to work, my people who didn't turn in homework today. Use your time to work. What?
I gotta go to work.
Go.
What?
Go.
Oh, okay.
Check in with April when you leave.
What?
Check in with April when you leave,
Okay.
so she knows. Okay, goodbye people in the video.